In this video, I would like to talk about how to identify significant results using probabilities instead of using the range rule of thumb. I have a probability distribution here, and all I know is that x is counting some number of successes. So we're doing some trial, and apparently x can take on values from 0 to 7, and that corresponds to us counting something. So maybe in a group of 7 students, how many of them have been late to a class this week, right? That could take on a value between 0 and 7. So every time we count something, when we count something that actually happens, we consider that a success, even if it's something bad like a student being late to class. So x is a random variable counting a number of successes, and we have this probability distribution. And I don't know what we're actually counting, but this really is a probability distribution. I have numeric data. Each probability is between 0 and 1, and they all do total to 1. And you can pause the video here and check that. So I want to talk about what it means to have a significant high number of successes and a significantly low number of successes using these probabilities. So, a significantly high number of successes is defined this way: x successes among n trials is a significantly high number of successes if the probability of x or more successes is 0.05 or less. And so we can write that as a probability statement. P of x or more is less than or equal to 0.05. Now 0.05 is the standard we use in this textbook. Just like we're using 2 standard deviations away from the mean using the range rule of thumb, those aren't really hard or fast rules. Those can be supplemented with other things. But if we're not told anything, we'll use the 0.05 requirement. Sometimes something might require us to use a 0.01 or even smaller tolerance. All right, so significantly high if the probability of x or more is less than 0.05. So if I look at 6 here, and I want to calculate the probability of 6 or more, well, in this data set, 6 or more would just be 6 or 7. Well, that's an or probability, and they don't overlap. So I can just add the probability of 6 and the probability of 7, right? So I get 0.03, which is less than 0.05. 6 is a significantly high number of successes. So 7's a significantly high number of successes, right? This kind of like becomes the first one, and anything more than that would be 2. But I'm just going to write down 6 is a significantly high number of successes. All right, let's write down a similar notion for significantly low. X successes I think I have one extra S up there. Well, that's embarrassing. I'll just erase it and hope no one noticed a few minutes ago. X successes among N trials. Is a significantly low number of successes if the probability of X or less successes is 0.05 or less, P of X or less than or equal to 0.05. So if I focused on one of the values in the table, like maybe I said 1, is 1 significantly low? Well, I'd have to calculate the probability of 1 or less. Well, here that would be the probability of 1 or the probability of 0. So again, using the addition rule, well, I just get 0.02, which is less than 0.05, which does in fact mean 1 is significantly low. Significantly low number of successes. Well, that tells me 0 is 2. But I have a feeling those among you who are really watching sharply know there's one more value that's significantly low. I asked about 1, but if I asked about 2, that would also turn out to be significantly low. Because the probability of 2 or less, well, that would be the probability of 2 or 1 or 0. Well, again, thinking about the addition rule for probabilities, I just add these three together and get 0.04, which is still less than 0.05. So 2 is also significantly low. So I have 3 things in this data table that are significantly low and 2 that are significantly high. Better said, I have two values of the random variable that are significantly high, and I have 3 values of the random variable that are significantly low. We could also have used the range rule of thumb to determine these things, and that's it for now.